some common reactions that just occur throughout nature here. And they're found all over the place in much more complex mechanisms than what we're going to be working on in class, but the fundamentals are there. And a lot of it is just acid-base reactions, but it's good stuff. It's very, very applicable. So for quizzes and exams that are coming up, I'm giving you the solubility rules and these reactions. You already saw the handout, and you have the handout, in fact. So with these 4 reactions is what we're going to emphasize today, not so much solubility rules. How do you recognize, see, because in all these 4 reactions it says acid, right? So, Connor, how do you recognize an acid in a chemical reaction? How would you recognize an acid?
The hydrogen.
The hydrogen, right. Always, you're going to have H and then something, right? And that's kind of how you recognize them, but probably even better would be you're going to know the 6 strong acids, and we'll get into that. But it's essentially that H out front, okay? How do you recognize a base in a chemical reaction? Here's base. And then manual, you see, oh, there's an acid. And then you see, it's a base, so it's got to be reaction number 1. How do you know it's a base? What do you got to see? Not solid. You got to see a what? Does anybody know? Hydroxides. If you see hydroxide, so the base would be something, and then you see this hydroxides, right? You see hydroxides. Then you know, base. Okay? So those things, just try to remember those. So we have these 4 reactions, and we have solubility to pick from. So what I want you to do is look at this reaction, in this first example, A, and identify whether it's reaction 1 through 4 or whether it falls into solubility. So we're not going to solve it. We're not going to predict anything. I just want to have some practice identifying reactions. So Kendall, this first one, what category would it fall into? Would it fall into solubility, or would it fall into 1 through 4? Now, let me give you a little guidance here. To make your life so much easier, right? I categorize this in my head as either solubility or 1 through 4. Now, the reason why I say that is because what's common anybody in 1 through 4? Acid. So right away, if you see an acid, like look at this first A. If you see an acid, don't even think about solubility. Stare at this 1 through 4 until you find it. All right? So let's change the question to Kendall. Do you see an acid in A? Yeah. You see an H out front, right? So we see an acid. So that means it's got to be 1 through 4, Sydney. Which one do you think it's got to be? It has to be 1 through 4. It's 4. Do you see? Now, the answer is 4. Now, you should probably be confused by this because you're thinking, well, what about this bloody calcium? Remember, we're going to write molecular. The next one's called ionic. Then it's called net ionic. Well, what cancels? I bet you that darn calcium is going to end up canceling. It's going to end up looking like number 4. So when you write that net ionic equation, I bet you in this question, those calciums end up canceling. So number 4. Paul, how about B? Solubility? Or one of those up there? He wants to say solubility, but look for that acid. There's an acid. So you don't want to say solubility. You see an acid, so you do not want to say solubility. Okay? So, Dylan, it's one of those four. Which one is it? It's number 1, because you saw the base. Right? Number 1. Okay, let's change the question, Lorena, to solubility or 1 through 4 for C. Solubility, or is it 1 through 4? It's 1 through 4. Good. So, Stephanie, it's 1 through 4. Which one is it? Number 1. Good deal. Lauren, D, solubility or 1 through 4? 1 through 4. Good deal. Yeah, you guys are getting the idea here. Bowdy, it's 1 through 4. 3. Great. Yeah, I agree. Do you see it? It's 3. All right. The last one here, Ashley, solubility or 1 through 4? Solubility. Right? There's definitely no what there? Acid. Okay, so it's solubility. Okay, so that gives you a game plan. So now let's get into the little peculiarities of all this. Not all acids are strong. In fact, there are many more weak acids than strong acids. Gazillions of weak acids. Very few strong. When writing molecular and ionic chemical equations, does it even matter whether an acid is strong or weak? Emily, what is this whole strong acid and weak acid thing? Strong acid? Weak acid? Ooh, well said. Did you hear what she said? Weak acids aren't soluble. In other words, they do dissolve, but they're not going to break up. Weak acids are all the vitamins, right? If they broke up, man, you'd have a gut ache. Your stomach would be even more acidic. And no, they stay together. But they have a little bit of acidic property. So that hydrogen pops off once in a billion. Out of all the molecules, 1 in a billion pops off, or 1 in a million. So it's a little bit acidic, but not very much. All vitamins in the world, for example, are like that. So it does matter. These weak acids, see, in molecular equations, we never break anything up. But in ionic equations, you're supposed to break everything up into its ions. So, for example, this, you don't know this. I'm going to tell you how to know it. This is a weak acid. And we got to write AQ on it. You can't write solid. That's vinegar. You have to write AQ on it because it is in water. In the molecular equation, it looks like this. And in the ionic equation, it looks like this. It looks the same. The molecular equation looks like that. The ionic equation, it looks like that. Even though you have a little AQ on it. It's weird. It stays together. It's a weak acid. So strong acids, no, that's not the case, right? So we should probably do a strong one, right? A strong, HBr. A strong is HBr. So if you have your molecular equation and your ionic equation with HBr. Molecular, again, don't break anything up. Ionic equation, break it up. H plus Br minus. So there's a big difference between weak and strong acids with these equations. Not in the molecular, because you don't break anything up. But in the ionic, you break it up if you can. And you can't break up weak acids because they're weak. So that kind of begs the issue, how do you know whether it's weak or strong? Because you can put H in front of anything. That's why there's so many acids. Well, there's only 6 strong ones. So, Kenneth, if it's not strong, it's got to be what? Weak. So that's my game plan. I know the 6 strong acids. I know them backwards and forwards. Because then if it's not on my list of strong acids, I know it's an acid, but if it's not on my list of strong acids, it's got to be weak. So I don't break it up. That's how I figure this out. So I suggest you doing the same thing. So we have to know these strong acids. There's only 6 of them, though. And they're all going to have H out front. And the real hint is, like chloric has a Cl, right? So that'd be HCl. Bromic, I'm just writing the, right, it's really HCl and HBr. I just like writing the charges in there. But hydroiodic, HI. So they're almost all those halogens, those group 7s. Now it gets, now you remember sulfate? Right? So that means you have to have 2 of those H's. And nitric, remember nitric was, nitrate was NO3 minus, so only have 1 H. And then perchlorate. Perchlorate, add an H to it, H plus. So those are our 6 strong acids: HCl, HBr, HI, H2SO4, HNO3, and HClO4. So know the names and formulas of them, right? Because look at the questions. The questions are like perchloric acid plus, right? So you have to know that perchloric acid is HClO4. So you have to know both of them. Okay, so we have the acids, sorry, we have the acids down, right? Don't break up the weak ones. But same idea with bases. There's strong bases and there's weak bases. So it's not as complicated though. Strong bases, you also break them up into their ions. That's the definition of strong. You break them up in the ionic equation. And given the chemical formula of the strong bases. Remember I gave you a hint on the periodic table that when we're writing these solubility rules, you always wrote AQ with anything from group 1 because it always breaks up. So the same thing with, that's all the strong bases are. Put a hydroxide with anything in group 1. You're done. You've got lithium hydroxide, sodium hydroxide, and potassium hydroxide because they're in group 1. So they're going to totally break up. You get your strong bases. So there they are. LiOH, NaOH. We can put the charges in there because you're going to end up breaking up anyway. And KOH. And there's always an oddball. There's always some job security in this, right? So ammonia is the oddball. Now, I don't know if you remember what ammonia is. Does anybody remember the formula for ammonia? NH, NH3, good, right? So when it reacts with, ammonia is an oddball base. So it interacts with an acid that forms ammonium. So remember ammonium was NH4 plus. So we want NH3, see they're only differing by an H plus. So ammonia is a base. It sucks up an H. So this is from the acid. Right? You see why hydroxide's a base? Because when it sucks up an H plus, it makes what? Water. H2O. HOH. Which is H2O, which is water, right? So that's why this is a base. So this is a base too, because it also reacts with hydrogen ions, but it forms ammonium. So it's an oddball. Hopefully there won't be too many of those. All righty, here we go. My job's done. Now it's your turn. Let's go to the boards and write molecular, ionic, and inorganic reactions for this stuff. And bring your cheat sheet, remember? Right? Tear out that equation, what is it? Exam 2 handout, right? Get used to using this. Bring the exam 2 handout with you. Yeah, just put it back in there when you're done. So let's try this first one. Write small, write small. Because at the top you have to write the molecular, and then you need to write the ionic, then the net ionic. So your first job in really all of these is to identify, remember the game plan. Is it solubility? Yeah. Just put it back in your. Is it solubility or is it 1 through 4? That's the first thing that I suggest you figure out. Is it solubility or is it 1 through 4? Right? It's 1 through 4. And which one? Number 1. Yeah, because there's a, what is number 1? Yeah, acid and a base. Good. It's number 1. So that's the format that you follow. All right. So it'd look like I'd help you out a little bit more on this to get you going here. All right? So it has to look like these as reactants. Then we're supposed to follow the format for equation 1. So as a product, right away, write what? H2O with a little L. And the little L is there to remind you, don't break it up in the ionic equation. And then plus the salt. So this H grabs onto that OH. That's what gives you your water. So when they say salt, they pretty much just mean everything left over, combine it. We have to name the cation and then the anion, right? So the plus guy has to be first. So what's left over? Well, I think life is kind of easier, I think, if you write little charges in here, but recognize you're going to have Na plus, and then this, remember what this big anion's called? Acetate, yeah. And if you forgot its charge, just really like acetate's charge is right down here. It's a 1 because you only have one H. So this has to be a -1, right? Sodium is a +1. And then before you move on, write A, Q, or S on stuff. Okay. Like pretty much everything is AQ, right? According to solubility rules. Except the water, you can't change it, that's liquid. And then make sure it's balanced. And if everything's good, go on to the ionic. That's where you break everything up that you can. You just can't break up solids and liquids, and that's about it. Oh, remember this guy. You only break up if he's strong, because he's an acid, special case. Right? Because otherwise, you remember that. We're used to playing the game where if you see AQ, you automatically break it up. But not with acids. Right? Only if it's strong do you break it up. So it's kind of a trick question there. We're used to breaking up everything. That's AQ. But not acids. He has to be on the list of strong ones if you're going to break them up. So don't break up that acid. Make sense? Now you need your arrow here, though. Oh. Yeah, don't forget your charges, otherwise they'll get docked. You have to have charges on your ions, plus and a minus, and then plus and a minus. Yeah. Now, one thing you forgot, though, is you write little subscripts on here, like AQ or S or whatever. Like this is an L.
Oh, right here.
Yeah, there's your AQ, and these guys are AQ too. And he's an L, according to this thing. Yeah, the ions we don't write AQ on, because they're ions, so they have to be AQ. I mean, you technically should. So now, ionic, you want to break up everything with AQ. Except remember, acids, you only break it up if it's strong. So that's why you got to know that list of 6. And he's not in the list of 6.
This is it, right here.
Yeah. So leave it as AQ, though. So you have to write it down here as AQ and don't break it up, just like you got it.
So that stays the same.
And he stays the same. But this one breaks up.
Even though it's AQ too?
According to solubility rules, right, he's going to break up. So everything is according to the solubility rules now, except we've got these dang acids that, man, it's AQ, but it doesn't break up. So the acid, anything with an H out front, you got to be careful.
Okay, so is that
So this guy breaks up too,
the
right?
Na?
This whole compound does, right? Because according to solubility, one thing that really helps me is you break up anything that has those alkali metals.
Okay.
Always break them up
Okay.
in the ionic equation. So this has to get broken up. Not this, 'cause he has an L on it.
Yeah.
And that one over there gets broken up.
So it's this right here and this right here.
Yep,
These stay the same and these stay the same because they don't break.
yep.
Okay. So
Because he has an L
Yeah,
and he's weak.
he's weak.
So don't forget your charges, Paul. Otherwise you'll get docked. So did you get a final answer here? So let's see. So the only thing that canceled was the sodium, right? So that acid is weak, so he does what an acid is supposed to do. He reacts with hydroxide and makes water. And then you're left with the acetate ion. Okay, so it makes sense. That weak acid, he's a weak, so he can't break up. Oh, I forgot my little AQ on him. Okay? So if you got it, try the next one. Otherwise, let me help you out. Make sure this makes sense. And you have to have charges on these ions. Otherwise, you'll get docked. L means liquid. Someone else. So you see what you're doing?
Yes.
Since you guys are down here, I can't see what you're doing. So which one is B going to fall into? Yes, that one. So write the reactants and then write down all this stuff. And the salt's going to be everything that's left over that you didn't write. So in B, yes, good. It's going to be reaction number 3. Okay. So when you use the cheat sheet to its full advantage there. Write down the products right away because it tells you what 2 of them are. G is gas. You won't break it up either. Okay. So what are you going to combine it with? It's K2SO3. Right? So what's going to be the rest of it?
Okay, is that what you like?
You're going to combine everything that's not used up. And what hasn't shown up yet is that I and the I and the potassium. Neither the I or the K, potassium or the iodine, has been used up yet. So that's what your salt has to be.
So how do you get 2, I was wondering, like, how did you get 2 hydrogens out of that whole equation? There's only 1 hydrogen.
We haven't balanced it yet.
Oh, okay.
So I haven't finished. So this needs to be Ki, then you got to balance it. Good that you noticed that. You got to balance it, just like Alyssa said. So after you write your Ki, make sure you balance it before you move on. Right? Because if I need 2 Ks, I'm going to need 2 of those HIs. Right? Make sure you balance it before you move on. And then write your subscripts. Okay, where did we lose you?
Okay, so can you break it to HI or no because it's a strong?
So okay, you have to finish this guy first. Finish this one first. So you wrote down K, so you wrote down the 2, gives SO2 gas plus H2O liquid plus the salt. So you haven't finished your molecular equation yet.
Okay.
Plus, so the S's are gone, the O's and the H's, just this I and the K. Yeah, so you don't write salt, you have to write what the salt is. It's a cation and an anion. It's going to be the K and the I.
Why is it the K and the I?
Because they're the ones that didn't show up.
Oh, okay.
They're not here.
Okay.
So it has to be the K and the I. And I like writing the K plus and the I minus because then I know how to break them up. Now you got to balance it though. You have 1 K, but here you have 2. So put a 2 there. But now you've got 2 I's, you only have 1, so you got to put a 2 up there. Okay.
You have H2O.
2 H's, 2 H's, it's good. Okay.
And that's the molecular?
That's the molecular. But put AQ and stuff on here first. Like everything is AQ.
Okay.
Pretty much, except for what they tell you. They'll tell you this is the
So
G.
the
That's
K
no.
is AQ, the SO3 is AQ.
No, this is one compound.
Oh, okay.
So you just write 1 AQ on there. And you should look at the solubility rules to make sure this is AQ.
Yeah.
I just know the solubility rules so well, that's why I put AQ on them.
Yeah.
But you really don't need to memorize them either.
You just check like this
Remember-
part right here basically, like to see if it's
Well, you don't even need to do that.
Yeah.
All those group ones
normally.
are always AQ. Yeah, you're right. If you're going to do the solubility, you pretty much look there.
Okay.
But I'm just saying, whenever you see that group 1, K, Na, or Li, they're always AQ compounds. You don't even need to bother looking. That's going to be AQ. And all acids are AQ.
okay.
And there's another K, so he's AQ. Right? Because it could be a solid with solubility rules, but it's not.
Okay.
Now you're ready to go for
And
the
then you
ionic.
separate this,
Yeah.
but you can't separate that, right?
Is he on the list of strongs?
Yeah.
He is, so you have to separate them.
So when it's strong,
You do
separate
separate it, yep. When it's strong, you do separate. That's what makes it strong.
it? Okay.
Okay, how's it going? Let's write down the solution up here, see where you guys are going. So does everyone agree with this up here so far? So if you agree with this, I got to get my... Okay. All right, everyone agree with the molecular equation? It's nice and balanced? You're good? Okay, that's molecular. Now we're ready for the ionic. So the ionic, you pretty much play that game. I'm going to break this up into 2 Ks and a sulfite. Do I break up the hydrogen iodide? Yes, because it's on the list. And I have 2 of them, so I better break it up into 2 H's and 2 I's. Do I break it up? Do I break up the gas? No. Gases you don't break up. Do I break up liquids? No. And again, I follow that one rule. Remember that one rule? Whenever you see sodium, lithium, or potassium, they're always AQ. You always break them up. So, and I have 2 of those. So I'll have 2 potassiums and 2 iodides. Okay.
Question. The salt doesn't stick.
So the salt canceled out on you. Now, you look what you did here. This is a huge difference. This is a molecule that's H2.
So it's supposed to stay like that?
Oh yeah, it has
Okay,
to.
I was just making
Has
sure.
to.
I didn't know.
Mm-hmm. Don't forget your charges. You got to have charges on everything. Plus, minus 2, right? And pluses and minuses. Yeah. And no, that's you copy that. SO2 gas, SO2 gas, H2O liquid, H2O liquid.
But okay, I have a question. How do you get that?
No, there's no. That's Ki. Remember, because K is a plus, I is a minus, so it's 1 to 1. Right? That goes down there. That goes down there.
Okay.
So to balance it, you have to. If you need 2 Ks, you can't mess with that. You have to put the 2 out front. So that's why you have a 2 out front. So now when this breaks up, you're going to have Ki plus Ki. So you're going to break up into 2 K pluses and 2 I minuses.
Halogen side.
Oh, that didn't cancel. Whoop. There it is. So keep going. Mm-hmm.
You know the grade on Blackboard that it gives you?
Mm-hmm.
Like, is that the correct grade? Or,
Well, it's going to be higher because we haven't dropped anything yet.
Well, it's just like I remember last year, like, as far as Belgium, she was saying that it wasn't, like, that's not the correct grade because she has stuff weighted differently.
No, I've done it all correctly.
No, for the ionic would be SO3, not SO2, right?
What did I mess up? Thank you. I should have Tootsie Rolls or something to throw out, right? That should be. All right. Thank you, Alyssa. All right. Thank you. What's that? Okay. So first, did you see how to? Did you identify what reaction we're talking about? Because you copy it. Because you said you identified the reaction. So you better copy SO2 gas and H2O liquid.
Okay, totally get that part.
Okay. So then, but it doesn't give you everything. It says salts. That means whatever's left over. So the S's and the O's and H's are done. So you look over here, the only thing left are the K pluses and I minuses. That's why that goes there. And if you write, and you always have to write the cation first. So K plus is first, I minus is second. But if you come back over here, I have 2 K's. So I got to put a 2 in front, otherwise I don't have my K's balanced. Then that screws up my iodines. Because now I've got 2 iodines. Now I got to put a 2 in front of here. Okay, then you put AQ on pretty much everything, following the solubility rules. And then you break stuff up for ionic. And you just got to be careful. You don't break up gases. You don't break up liquids. And you don't break up the acids that are weak. And everything else gets broken up. Anything with Na, you always break up. He's on the list of strong, so that you're going to break up.
So then when you go down to the
What's that?
when you go down to the second step on the ion, why did you start with like the 2K?
Because this breaks up into 2K pluses and breaks up into that. This is that, this is that. All right?
Oh, okay, so you wrote it in order.
Yeah, I wrote them in order. This is that, this is that, this is that, this is that, this is that.
All sides balanced. That's why you put the 2 in front of the H.
Yeah, because there's no more balancing now. It's done. This is balanced. So now all I do is break everything up.
We didn't have to do that on the last one because they were both balanced. Because those were balanced.
Yeah, we didn't have to multiply by 2 or nothing. Here, it's already balanced, so don't worry about anything. Everything's balanced, so just break everything up. So hopefully you recognize C as number 4. That's going to go 4. And before you move on, recognize the C, the sodiums aren't balanced, right, before you move on. So you better put a what out in front of this, right? You cannot, remember to balance, you can't do that. You can't do that. You have to put the 2 out front because this is a plus, that's a minus. So these have to be 1 to 1. It looks balanced now, right? Oh no, now I got 2 nitrates. I screwed that up. Yeah, thank you, Emily. Okay, now it looks good. And once it's balanced, then go on and write your ionic. Now you don't have to worry about balancing anymore. Just break up what you have. The sodium sulfide gets broken up into 2 sodiums and a sulfide. The HNO3 is on the list of strong acids. Better break them up. You got to break them up into 2 H's and 2 nitrates. H2S, a gas. Ooh, don't break it up. Sodium nitrate, better break it up. 2 sodiums and 2 nitrates. Get to work, get to work.
Where did you finish that one?
Well, keep going. It's good practice. You can tell a story in 4 minutes. Okay, is this making sense to you guys over here?
A little bit.
Okay.
I mean, I think I think it is when it's becoming like, I don't know. I'm still kind of having a little
Okay.
issue.
I think what would help you is if you just wrote more up here. Like Na is a plus, right? And S is a -2. Because then when you break it up, it's so much easier. S -2. Now I've got 2 of these Na pluses. It just looks easier. And this is H plus, NO3 minus, right? It kind of helps. I don't know.
Yeah.
Maybe.
I'm just having determining if it's like I don't know all the gases.
Oh, you don't need to. That's why you just copy it.
Really? Oh, it says.
It's all right here. So you don't so the first thing you do is write down, use your cheat sheet.
I still knew that. Okay.
Right?
Are we gonna have this?
Yeah. Yeah, like 4 times.
I was confused about the same thing Nick was doing. So basically, what I did up there
So
is right here.
it's the acid. It's an acid plus the S minus 2. So it's got to be this number 4. So the first thing you write is H2S gas. And that's what you did. You just forgot to write the G. Because you write the G, otherwise you might break it up down here. So you keep writing that G.
I saw you doing it up there, but I was wondering, I didn't see this down here. I didn't pay attention.
Oh, yeah. Otherwise you have no clue. How would you know it's H2S gas? That's way too much. So yeah, the first thing you do is identify the reaction and then copy these parts down. That's the first thing I do. Otherwise I screw up. How's it going, Mia?
Put a 2 right here. You have to have.
Yeah, no, K is a plus, BR is a minus. That's KBR.
Oh, okay.
So if you need 2 Ks, you have to put a 2 out front.
How come we write off first? Why did we write off 2?
All right. So on D, the very first thing I did is identified its reaction number 2. So right away, write CO2 gas and H2O liquid from the cheat sheet. Right away do that. And then you combine what's left over. I haven't used any Ks and I haven't used any BRs. Remember, K is a plus and BR is a minus. right? So that's how I do these. And then, like Alyssa or someone noticed, darn, I don't have enough K's. So you can't do that because BR has a -1. So this has to be a 1 down there. So if you want 2 K's, you got to put it out front. And now I screwed up my bromines, so I got to put a 2 in front of the HBr. Exactly. And then you write, follow the solubility rules to write AQ on everything. Everything has a K, so it's all AQ. So the molecular is all the work, I think. If you get that right, you are in good shape. So we're about out of time, but come by and we can practice some of these if you'd like. Work on your homework and come by. I'll be glad to help you out.